Welcome back, Physics 30. This is the second friction booklet, part 2, and it pertains to the duotang pages 12 to 22. So with this one, we'll be looking at situations in which it's desirable to increase or reduce the amount of friction between surfaces in contact, give examples of various ways in which frictional forces can be either increased or decreased, explain that the normal force acts to oppose the force of gravity, at least in situations in which the surface is flat. Explain the normal force must equal in magnitude and in opposition direction to the force of gravity for the object to remain in equilibrium. Explain the structure supporting an object must be capable of producing a normal force to withstand the force of gravity acting on the structure of the object, otherwise it will undergo failure. Draw free body diagrams to illustrate forces concurrently on an object and solve problems involving kinetic or static friction, so moving or at rest. So the first part of this book will look at situations involving objects on a flat surface, and then there'll be a quiz for that, and then the second part looks at inclined surfaces, and there'll be a quiz concerning that one. Okay, so there are tons of examples in the book. Here's some that we'll do together. You push a 25 kilogram wooden box across the floor. We're told that the coefficient of kinetic friction is 0.2, so the ratio of the force of friction to the normal force is 0.2 for the the wooden box on the wooden floor. Now it's being pushed at a constant velocity. So if it's being pushed at a constant velocity, that means that there's no acceleration, so the net force must be 0. Okay, so the friction force and the applied force must be equal and opposite. Now it says here, how much force do you exert in order to achieve this? So first of all, we know the kinetic, so the things that we know here, we know the kinetic, the coefficient of kinetic friction, we know the mass of the object, and that's pretty much it. So if we look here, kinetic friction, the coefficient of kinetic friction equals the force of friction over the normal force. So we can solve for the friction force, the kinetic friction force, because we know what mu k is, and we know what Fn is, somewhat. If we take a look over here, F, since it's on a flat surface, this would be the free body diagram. My applied force is equal and opposite to my friction force, and the force of gravity is equal and opposite to the normal force. So those have to be equal, and these have to be equal. So if I can figure out what Fg is, mass times gravity, 25 times negative 9.8, I get 245 newtons. So if force of gravity is negative 245, I know that the normal force is positive 245, as we can see here. So coefficient of friction multiplied by the normal force, I get 49 newtons. So all I did over here is I just illustrated that Fn is equal to the opposite of Fg. So if I take the negative of Fg, I get 245. So if my friction force is 49 newtons, then my applied force must be 49 newtons in the opposite direction. So we're not concerned about how the object got to be moving. We're just simply looking at it. It's already moving. I'm applying a force, so the force I'm applying must be equal and opposite. So Fa is equal to negative Fg, or sorry, Ff, or Fk, whatever you want to call it, kinetic friction or just friction force, so it's 49 newtons. Next one, a boy exerts 36 newtons horizontal force as he pulls a 5.3 kilogram sled across the cement sidewalk at constant speed. Again, we have constant speed. Our free body diagram is going to look like this again. Our applied force must be equal and opposite to the friction force. What is the coefficient of friction between the sidewalk and the metal sled runner? So we're looking for concrete and metal. The coefficient of kinetic friction will be different than this number. So we know the applied force. If we look over here, we know the applied force. We know the mass of the sled. We don't know what mu k is. And we know that normal force is equal and opposite to gravity force. And we also know that Fa is equal to the opposite of Ff. So two key things there. This and this. So if we know we're applying a force of 36 newtons, we must be having friction the same way. Now, first of all, I decided to do Fn first of all. So figuring out the force of gravity on the sled, mass times gravitational acceleration, 5.3 times negative 9.8, I get negative 51.94. Normal force is equal and opposite, so it must be positive 51.94. Now that I know that, I can figure out what mu k is, because I know that the friction force must be equal and opposite to the applied force. The normal force, I've already figured it out. Now you may notice in this equation, friction is treated as just a magnitude only, no negative. So even though it's friction, we don't include a negative value for there. It's just simply 36. If we're using another equation, though, we have to assume that friction force is negative, working against you. So 36 over 51.94, and I get 0.69. Okay? So we can see that constant speed implies it's not accelerating, and if it's not accelerating, there's no net force. All the forces must balance each other out. So Fg and Fn are equal and opposite, and applied force and friction force are opposite. Okay? Not too bad. Next one, so we'll look at ones involving acceleration happening. An applied force of 40 newtons accelerates a 5 kilogram block at 6 meters per second squared along a horizontal surface. So this time it is accelerating. If we have acceleration, then you have a net force. So your free body diagram is going to be slightly different in that Fa is going to be bigger than Ff. Fg and Fn are both equal and opposite, so they balance each other out. And some of the applied force will be used to oppose friction, and what you're left with is net force. Okay? So to determine how large the friction force is, let's see what we know here. We know the applied force is 40. We know the mass is 5. We know the acceleration is 6.00 meters per second squared, and we're asked to find F. So what we're going to have to do here is figure out what F net is. Because if I know what F net is, I'll be able to use this equation from earlier on. F net is equal to all the applied forces plus force of friction. I mean, since Fn and Fg balance each other out, we don't have to worry about them. We know they're going to balance out, so we're only concerned about their horizontal forces here. And earlier, Newton's second law, F net equals mass times acceleration. Mass times acceleration, 5 times 6, 30 newtons in the positive direction. So here we have our net force of 30. We just figured that out. And our applied force of 40, so you can see here what the answer is going to be. Obviously, Ff has to be negative 10. It's 40 combined with negative 10 will give me 30. But mathematically solving for that, subtract 40 from each side, and I get the force of friction is negative 10. Okay, so the key things here, figure out if it's a situation that's involving constant velocity or acceleration. Write down the information you know, then come up with a plan to figure it out. And lastly here, before we cut the video off, determine the coefficient of kinetic friction. So we need to know mu k. We're looking for mu k. We need to know the force of friction. We know that. And we need to figure out Fn. I don't think we figured out Fn yet. So, nope, we didn't do that, so we have to figure that out first. It's equal and opposite to gravity. So we have mass times gravity. Or what I did here, if you notice, I just simply put, since I know Fg is m times g, Fn is equal to the opposite of that, so negative, negative, and you'll get your answer right off the bat. Or you can figure out what Fg is and apply a negative to it to turn it into a positive. So 49 newtons we get for there, and so kinetic friction from the previous page is 10. Remember, you include the negative with this equation. Fn is 49, so we get 0.204 as our coefficient of kinetic friction. Okay, so there we go. That's the end of part 1. We'll come back with part 2. We'll look at this one. It's also one involving acceleration. You may wish to take a look at it, see if you can figure it out, and then come back and look at the video. Okay, see you soon.